Hey guys, it's been a week. Hope everything's going well. From what I've heard, things seem to be going fairly well for most of you. I appreciate you guys working with Miss Klein. You have no idea how nervous I am to leave you people, and I think she's fantastic, so I know you're in good hands. But I am home now, and I've got a fancy contraption around my neck, which does not allow me to look down. So this could get fun. All right, I've got this thing rigged up, so I kind of reach out to give you the notes. So I'll do my best to hope that they're under the phone. Funny story, I just did this a few minutes ago and realized I videoed everything upside down. So I had to step away, say some words to calm myself down, and I'm back. All right, so take two on this. But just a little disclaimer here, because the rest of these notes that you guys get in the video help here is going to come from my house. And most of you know I live in what I call Lentz's Wild Kingdom. So if you hear a cat yelling, that's Ethel. She's perpetually cranky, all right, thus her name. And if you hear a dog barking, that's Lily, announcing that somebody walked on our sidewalk, or maybe they even just thought about walking on our sidewalk and she would still bark. And then Earl, if you hear some wings flapping in the wind, he may fly in here just to see what I'm doing because he is naturally nosy, all right? So I'm going to do the best I can here. If you hear me clearing my throat a lot or gagging, I promise I'll be all right. I'll step away, but there's a whole lot going on in that neck region right now. So we will get through this. But first thing you're going to do, if you take a look at your tracker sheet, LT5 is loaded. It doesn't look like it's loaded, but this is a new unit, and I've got to tweak some things yet. But this thing includes Kepler's laws, which is like a 2 to 3 day process. So you will not be taking LT5 today. You will not be taking LT5 tomorrow, all right? And that's good, because some of you, from what I've seen in Power School, needed a little chance to catch up with targets 3 and 4 mainly. But LT5 says I can use mathematical representations to predict the motion of orbiting objects in the solar system. What I don't say explicitly that I need to is that these are Kepler's laws. All right, so we need to use Kepler's laws to predict the motion of these orbiting objects. And the first thing I want you to do with Miss Klein is to do some Googling. And I've seen you guys, you're master Googlers. So you're going to Google the words geocentric, heliocentric, Ptolemy, and Copernicus. And I think fairly quickly you guys will see how those four are put together. And I'd like you to have a quick chat with Ms. Klein about them, what they mean. Hopefully you understand which view is the correct one now after a couple minutes of either smartphone Googling or Chromebook Googling. So use your technology for the good. And please pause me at this time. I'm not going to stop here. All right, I'm going to keep rolling. But pause me, have a chat with Ms. Klein, and then come on back to me. You guys have no idea what it's like trying to drink a can of Diet Mountain Dew without tipping your head back, all right? There's an art to this, because Diet Mountain Dew out of a straw just doesn't taste the same. So I want you to know I'm struggling with that. But here we go. First law of Kepler's laws. So not the first law of motion, but the first law of Kepler's laws. When you did this Googling, with a whole lot of luck, you no longer believe in the geocentric model. All right, and unfortunately, we do all know those people still that believe everything does revolve around them. But in physics, we know that that is just not the case, at least. And so we are under this heliocentric model, which was thought of by Copernicus. And this is the idea. Helio means sun, centric means center. All right, so sun-centered. It's the idea that the planets are going around the sun. And that was some big thinking there, all right? That wasn't accepted at first, but we do now know that we are all going around the sun, and the path that we take is what we're going to focus on today, because it's not a circle. Think about a perfect circle and just understand that's not us, all right? That's not us. And what Kepler did is they used some things, some math, to kind of prove that idea. So the first law is called the Law of, squeeze this in, the Law of Ellipses. And what it says is that the orbit of a planet is an ellipse with the sun at one of two foci. Okay, now, as I've mentioned, you guys have a mathematical mind in front of you while I'm gone. And so Ms. Klein, I'm sure, can explain this idea of ellipses in far more depth than I could. What we need is just kind of a basic understanding. And probably one of the words here that you might not understand is a foci. And I Googled it, because I don't know, is it foci, foci? It's like, man, this is official, I gotta put my voice on video. But apparently, in America, you can say it either way. So whatever lights your fire, all right? Foci or foci, I think I usually call it foci. But the bottom line is, a foci, an ellipse has two of these things within it. An ellipse, in simplified thought, is just a flattened circle. It's almost just like an oval. And the oval I'm going to draw is an exaggeration. Okay, when you guys look at the couple simulations here within the next few days, you're going to see that the elliptical orbit that we're in is not super flat. All right, so we've got the sun, and then that is one focus, and then there's going to be another imaginary focus. Okay, so those are the two foci. The Earth and the other planets are tootling around the sun in this elliptical orbit. So I'm going to draw this the best I can, reaching out here. Come on. Not horrible. I've seen worse. All right. So we've got this elliptical orbit. We'll put the Earth right here. And I don't know why the Earth is bigger than the sun, but apparently it is today. All right. But the Earth is going around counterclockwise. Okay, the Earth is going around counterclockwise. And at first it made sense, well, if we're going around the sun, that's fine. The sun's probably right smack dab in the middle. But then we figured out that something's going on where we're going faster in some parts of the orbit than others. And the way they deduce that, we'll talk about later. But just realize it's not like scientists were staring at a speedometer and say, whoa, man, we're speeding up, or whoa, dude, we're slowing down. It's not noticeable, all right? So there's a slight change in speed, and they couldn't really figure out why. But think about this. We know then, if the Earth is right here, let's just say the Earth is right there, it's closer to the sun. And if things get closer together, like inverse square law says, we know that the force gets a lot stronger. So as the Earth is coming around this direction and getting closer to the sun, it's going faster. So it's speeding up as it's coming in closer. And it's cruising, man, right here. But then, due to centripetal force, something we don't talk about, just force in a circle, we keep going, all right? So the sun hangs on to us, but we're going to whip right on by. But as we're going over here now, so if the Earth is over in this part, it's getting slower because we're getting farther from that force. Okay, so we get farther away from the object, the force weakens, we slow down. But we're going to turn around the corner, and as soon as we get up in here, we're going to speed back up and come towards the sun again. All right, so that's the gist for right now of the first law. And like I said, these notes are going to be divided into multiple parts. So for today, just know, all right, law of ellipses, we're in an ellipse. Each one of these is a foci. We can see this one because the sun's at one of them. Realize that one's imaginary. If you're ever out in a space shuttle cruising along the solar system, you're not going to, somebody's not going to say, oh, look over there, it's the other focus point of the solar system. They're not. Okay, there's nothing actually there. It's just an imaginary point. All right, so what you're going to do is pause me. You're going to look at another video that is already on Moodle, and it's not me talking. You may appreciate me talking more after this one. This guy's not super exciting to listen to, but the pictures are better. All right, so just suck it up. It'll be all right. You're going to watch like 7 minutes and 14 seconds of that video, and then you're going to come back to me to talk about the solar sister, that's awesome. All right, solar system, there we go, Explorer Gizmo, and I'll get you going with that. All right, see you in a minute.